Welcome back to the Code Wolf. I'm excited for today's video. I think this might be one of the most interesting topics on the channel yet. I'm going to demonstrate how to use OpenAI to chat with a relational database using natural language, no SQL queries required by the end user. So for example, in the demo we'll explore, I can just type something organic and the AI will be smart enough to convert that into a fairly complex SQL query, return the results, and return the raw query and a summary of its understanding of this task. Now, I created this video because I see a lot of AI plus data demos out there that just focus on how to query documents or loosely structured data, but they don't really get into things like relational data, and that's what a lot of developers out there work with day to day, and relational databases are still powering a ton of apps. So I wanted to see what we could do with AI to communicate with those databases. The results were actually better than I expected. We've got our work cut out for us in this video, so let's dive right in. All right, so let's take a closer look at the app that we'll be working with throughout this video. Now, this app is currently hooked up to an Azure SQL Database and an Azure OpenAI service, but I want to stress that all of the concepts we'll be looking at could apply to any relational database like MySQL or Postgres, and any variation of the OpenAI service as long as it's using the GPT-4 model, which we'll talk about a little bit more later. So over in Azure, I have this database set up, and what's nice about the Azure SQL Database is that it actually gives you the option to populate the database with sample data when it's created. So you can see we have tables of customers, employees, orders, products, and so on. And this just gives us enough data to perform some interesting queries with as we experiment with our app, because we all know that seeding databases with sample data is a huge pain. Now, our OpenAI service, like I said, is using a GPT-4 model. We'll look at these two services more. Just understand that this app is hooked up to just these two services and nothing else. No search services, no indexing from cognitive services or Azure AI search or anything like that. And let's see what this app can actually do. So for example, if I was to say, show me all of the products, and then hit submit here, sure enough, we get a list back of all of our products that are currently in the database. And of course, we get a summary here of what the AI's understanding of the request was, as well as the SQL query that it generated. So our AI is essentially taking our natural language and converting that into a SQL query, which we then run against our database. It's really that simple, but there's some specific configurations we have to apply to our AI model and our database to make this work properly. Now, we can go a lot further with these queries than just listing products. So let's start with another simple query and build off of that. So if I was to say, show me all of the customers, click submit. There we'll see all the different customers, and we can even add filtering here. So we could say, who live in Germany. So I'll submit again here. And this time you'll notice over on the right in our country column, all of these individuals live in Germany. And what's interesting about this is we can use different variations of this language and it will still work. So I could say, retrieve all of the customers who live in Germany or something like that, just different variations, and we'll still get the same results back. Now, if I were to grab one of these names, we could also say something like, retrieve all of the orders for this individual and submit that. And this time we'll get a list of order data back. So we have all our order IDs on the left. It looks like this user had 6 or 7 orders, but more importantly, look at this query that this generated. This is actually getting into somewhat sophisticated employees. So we're now doing joins and filtering, and we can go even further than this. So we could try something like this example where we say, show the total price for all of the orders for Hannah. And now if we look at this query, this is getting even more complicated. So we're doing math, we're doing multiple joins here. So we have a join here and a join here, as well as filtering. And this is actually working out correctly. And we can further refine the results even. So I could say something like round to the nearest dollar and format as currency. So maybe we don't like this weird decimal price down here. But if we add in this additional help for our query and hit submit again, then sure enough, we actually get our total price formatted as dollars, and this time it even brought back a column with the person's name. Now, that is one kind of important detail here is that these queries and the results can vary slightly when you keep resubmitting them. The data itself will still be correct. It's just that slight variations in the query formatting and such can kind of adjust which columns come back, but the data is still accurate. So this one is correct, as was the one before it. So if you were to take this SQL query and just run it directly against the Azure database, so if I were to copy this, and then just go over to our Azure portal and paste this in here. So we've got this long query in here and run that. You can see that we get the same result back here, which is really interesting. So even this really complex query, when we run that, it is accurate and we still get the same results. So let's take a little bit closer look at how this app is architected and then get into actually setting all this up. Now, for the app architecture itself, let's break this down into individual pieces. So of course, we have our browser, that's what we were just looking at, and the user sends in a human formatted question. So that's that natural language I was talking about. And that gets sent to the back end, which is just our app running locally on our machine, but that could also be deployed on a server, of course. And once our app receives that request, it actually sends that human formatted question out to OpenAI. And remember, this is using the GPT-4 engine. That's really important for this video. And that's going to return our SQL query. That's going to convert natural language into a SQL query, send it back to our app, and then our app runs that SQL query against a database. What's really important here is that this can be a local database, it can be an on-prem server database, or it can be a database in the cloud, but it doesn't have to be, and that's not always true of other solutions. So for example, if you're using certain search services to index your data, a lot of times those require the database to be in the cloud, and the indexing doesn't give you the full level of control. We'll come back to that in a minute. But long story short, this can be any database, and that's going to return our data set. Now, our app takes that data set and handles some of the unknown structure of it because every query is going to come back differently. So we kind of massage that data and display it in a human-friendly table back in the browser when the page renders. And we'll look at that code in a minute. So next, let's take a look at how I actually set up this database for demo purposes if you want to follow along. So you will need an Azure subscription for this. Go ahead and sign up for a free trial if you want to go that route, or if you already have a subscription, that's great too. So I've got a handful of databases here that I was experimenting with. We're currently hooked up to this AIDB full, which has the most sample data in it. But just go ahead and create a Azure SQL database. I'm not going to go through this whole process, but just pick this SQL database option. So I'll say create, and it'll take you through this wizard, but I just want to point out a few important points here. So the first thing is that you'll want to make sure you create a new database server. So if you don't already have a server, make sure you do that. I have created one here, but then you just enter in a database name. And you can leave most of these settings at the default. Just any sort of general purpose tier will work for this. Be careful of your costs. Databases can get expensive, so make sure you're checking the pricing on this. And the other thing I want to point out is that if you're working locally, you'll want to add your current client IP address as you're configuring this database. And one other thing here, under additional settings, you'll want to choose sample. So this will allow you to load in the AdventureWorks LT database. And so you can see where it says use existing data, just make sure you populate that sample data and then go ahead and create this database. But other than those ones I pointed out, you can pretty much leave all of your settings at the default. Just make sure that you're creating an Azure SQL database and not some of the other options out there. And that's really all that we have to do for the database. So if I were to go back to Azure SQL, what that'll do is if we go into our query editor here, that's what gives us this whole set of nice tables pre-populated with sample data. And this is actually a really nice database to work with when you're trying out these queries, because this schema is complex enough to be meaningful, but simple enough to be approachable, and I really like that. So just make sure your database is set up properly. Now, to create the OpenAI service, you'll want to go to Azure OpenAI here, and on the screen, just choose Create. And again, this also works for regular OpenAI if you're not using Azure, but I'm going with this approach because I like this workflow. So go ahead and create your OpenAI service. Most of these settings, again, you can just fill them in with common sense and some default values. There's nothing too special to configure here. And once you've got that created, so I'll go into the one that I'm hooked up to currently, then we'll just want to go down to model deployments. And this is the important part. So let's open up our model deployments in another tab here and see what we're dealing with. So you can see I have this deployment name called Wolf2, but the important part is this GPT-4 model name. You have to make sure you're using GPT-4 or this probably will not work as well as you'd hope. So when you go to create a new deployment, if you haven't set this up already, when you choose a model, make sure you choose GPT-4. Now, you might have to play around with which version here. I had to deploy a preview version, but it still worked fine for this demo. So just make sure that you choose GPT-4. One thing I should also mention is if you don't see GPT-4 here, that could be one of two reasons. It could be that your subscription for some reason doesn't have access to it, or it might be that when you created your AI service here in Azure, you chose a region where GPT-4 is not yet available. For this example, I chose East US 2, so you might have to experiment or look up which regions currently support GPT-4 because that's the version you'll want here. All right, so now let's actually look at the sample app code that's making all of this work. Now I'm using a Razor Pages project for this just because I think they're simple and easy to understand for this type of work, but this could be adapted to either other .NET options like Blazor or entirely other languages like Node and things like that. So the important thing to understand here is that when the user submits this form, that is going to run this onPost method. So everything inside this onPost is what powers our app essentially. Now again, I have other videos out there that show you how to connect to OpenAI in more depth at a slower pace. So I'm going to kind of breeze through the connection part and just focus on how we configure the model and retrieve the data from our database. So the most important part for connecting is right here. So we need our endpoint, our key, and our deployment name for our service. And you can go out to Azure and get those yourself. So on your AI service, you'll look under keys and endpoint, and that'll give you your key to copy as well as your endpoint. And then of course the model name is right over here. So that's Wolf2 in this case. So you'll just plug in these values yourself, and that will allow you to create an OpenAI client here to actually talk to the AI service. Now, this system message we'll come back to in a moment. This, if we expand this, is what's actually configuring our AI service. But let's look at the rest of this first just to get a general idea for the flow. So once we have our client created that connects to the AI service, we send it some chat completion options. And that includes a couple of messages. So we're sending two messages. One is the system message that we'll look at in a moment, and that's what's configuring our AI service. And then the next one is our user submitted question or query. So that goes through as a user message, so we actually get a response back. So you can kind of think of this as the system message configures the AI, and then the user message actually talks to the AI and wants a response back, and we pass along that deployment name. So this is kind of the overall message that we send to our AI to start our conversation. So then we call this get chat completions method to send that out and get a response back. Now, when we get a response, that's going to come back as JSON because of the configurations that we'll look for in a minute. So we just serialize that into an AI query, which is a simple little model down here that has a summary and a query. So over on our homepage here, this is our summary and this is our query. So our model just kind of corresponds to this. Now, we also use that query that comes back to talk to our database. So you can see we have this data service.get data table, but we'll look at the database side of this in a moment. For now, let's expand this system message and see what we're actually sending over to our AI to get our SQL query back. So this essentially uses prompt engineering to help our AI understand what kind of data we want back, what the format of that data should be, and most importantly, it also helps our AI understand the schema of our database. I want to stress that the AI in this setup is not hooked up to our database, and that's kind of the unique part of this. Our AI doesn't know about any of the individual records in our database. It's not indexing it or anything. It just understands the schema, and so it's able to generate queries based off of that. So if we look at this, if I kind of format this a little bit better here, we're saying you are a helpful database assistant. Use the following schema when creating your answers. And this is where we define the schema for our database. So to create this, I essentially went out to our Azure database. And remember, we had that list of tables. So I'm just taking those tables and listing some of them here. You can list as many as you want. And I'm providing the column names, including the IDs. And the GPT-4 engine is smart enough to understand the schema based on this data that we provide. And that's the key reason we need to use GPT-4 is that it's much better at understanding schemas and generating SQL from natural language than the other AI models like GPT-3 or some of the other ones. We want to make sure we're using GPT-4. Then we also tell it to include column name headers in the query results so that we can build a nice looking table. And we tell it to always format the response as JSON. And this is important because that allows us to deserialize the data into our app. So we tell it output only JSON, this is your template, and replace your summary with its understanding of what the query is. And then we tell it to replace your query with a Microsoft SQL Server query to retrieve the requested data. That's one of the most important parts of this. This is telling it to build a query. And this is also where you can change this to be MySQL or PostgreSQL. Some of these different relational databases have slightly different variations of the syntax that they're supposed to use. So until I added this in, it was actually generating MySQL queries by default. So certain minor syntax differences were really causing a lot of errors. And as soon as I added this, things started looking better. And I even double enforced this by specifically saying not to use MySQL syntax, and the AI model is smart enough to understand what that means. And finally, this line here to always include all columns in the table. This helps with preventing minimal data sets coming back, so sometimes I'd only get one or two columns that it thought were important, but this way we get a full set of columns back from the tables that we're querying, and it just provides much nicer looking or more informative results. So I think this is really cool. We're essentially using prompt engineering to translate natural language into SQL query responses. And what's great is that you could parameterize this as well. So you could kind of dynamically load in schemas, or you could change the JSON output to get different pieces back. You could change this to a different database provider. This small block of code is so powerful thanks to the amazing capabilities of the GPT-4 engine. So by the time we reach the bottom here, we have our query back from the AI, but now what do we actually do with that query? So the query isn't that useful by itself, and that's why we need this data service.getTable method. So if we head out to our data service, and we kind of scroll through here, this is building a SQL connection, and this is just using data again from our database service out there. So if you go out to your database, you can get a lot of that information from the connection string information here. You just have to piece together the required parameters for a SQL connection string. Now, in this case, we're using the SQL command class in C#. And a lot of .NET developers might not actually use this that often because they're so used to working with Entity Framework. But in this case, we don't want to use Entity Framework. We want to just run raw SQL commands. And to do that, we use the SQL data reader and we execute. And then we get this reader.read method. And by combining that with a while loop, we're essentially looping through however many rows come back from our query. So this essentially allows us to handle the dynamic nature of all these changing responses. We don't have to define a data model in our app or anything like that. We can kind of just read in the rows and columns as they come in and build out a table using that. So you can see here, we're looking first for our headers. So this will get the names of all the headers for the columns that come back. And we have a flag here where after you read the headers once, just ignore those from now on because we don't want to add in the headers for every row of the database. We just want to add those in once. And then here is where we're continuing to loop through all of the rows, and we're essentially building out a list of lists. So if we look up here, our rows are a list of lists of strings, and that way we're creating a list of rows that are each a list of columns. So we get kind of this nested data structure going here. And those rows are returned back up to the main onPost method. So if we head back here, you can see we're getting the row data back, which is a list of lists that contains all of the data. Now, the last step here is just to display that. So over in our HTML markup file here for Razor Pages, we have a table that just loops through every row in the row data and loops through every column and just kind of dynamically builds out that table. I think this approach is really cool. It's very open-ended. So basically, whatever data table you get back from your database and the AI query, the UI will be able to handle displaying that, which is really nice. And then up here, we just have some basic conditionals to display the summary and the raw query if those were provided, or we can even show error data if that happened. Now, I do want to mention that this is by no means enterprise level code right now. This is just sort of stitching together the different pieces of our app to display it in the UI. You'd want much better error handling and checking of the available data and things like that. But this does work surprisingly well. This is actually not that much code relative to what it's producing for us. Now, the last thing I want to talk about is the option of using a search service to achieve some similar results. So you might see a lot of demos out there that use Azure AI or Azure Cognitive Services, and they hook up to the Azure SQL Database, and that allows you to query the database using either REST endpoints or some natural language capabilities. But there's a few key differences here that I want to point out. The first is that just the general way that this thinks about our database is a little bit different. So if I were to go to Add Data Service, right now I'm in an Azure AI Search Service, and this lets you pick a data source. Remember, I mentioned a lot of demos out there just use blob storage or loosely structured data pools. But if I were to choose something like Azure SQL Database, now this will let me connect to it and start to query certain things. But the interesting point here is that it makes you pick a table or a view. So if I were to connect to our database, we could only pick from one table or one view at a time. And the reason for that is that this search service, from my understanding, is sort of set up assuming you're going to surface a large table or you're going to surface a view that's already the result of a predetermined SQL query. So maybe a view that shows a lot of products with their categories or a lot of joined order data, some sort of large data set that you want the search service to consume. But that's not the same thing that we were able to do with our app. This sort of assumes you're prepping your data or structuring it in a way for the search service to consume. It doesn't just organically query across all of your different tables with the existing structure like we were able to do with our AI. Now, if I'm wrong about this, please leave a comment in the chat and we'll talk about it. But my understanding so far is that with these search services, they have certain limitations and different expectations of what you're trying to do. You can do powerful things with these search services, but they're just not the same thing that I was looking for when I actually built out this demo app. And that's why I was so interested in this, because it's kind of an alternate option to some of these existing resources. Most of these search services also require direct access to your database to crawl them or index them or scan them in some way. Whereas our solution, the AI search, is actually completely decoupled from the database and has no access to it. So I hope you enjoyed this video and learned a lot. I think this is just an interesting experiment in terms of prompt engineering and querying a database with AI and kind of stitching these different pieces together in creative ways. Let me know what you thought in the comments and let's discuss. Thanks so much for watching.